is the session. Or if you want to go back and look at something, happy for you to do that. So those are available in the learning management system. I'm going to share my screen now. Remember, as we go through the session, put questions in the chat as we go. Questions, comments. I'll look through those as we go. But we ended last session at this point. And well, why not? I'll give a quick prize out for somebody who can give me a formula for risk. A formula for risk. Anybody got like the international formula for risk, actually? Can anybody in the chat pop that down? Risk is something times something. Well done, Drew. Drew's on it. Prize for Drew. Likelihood times consequence is the international definition of risk, really. So, and I'm not talking about just road safety risk. I'm talking about risk. So financial risk, environmental risk, health risk. It's what is the chance a bad thing will happen, and multiplied by the magnitude of badness. So what's the risk of recession? Well, it's the chance we go into recession multiplied by how deep a recession is. That's the risk of recession. And so in a safe system assessment, we I should say, we have used this as the definition of risk in road safety for a very long time. What's the chance of a crash multiplied by, how bad is that crash going to be? Is it going to result in death and serious injury, or is it going to be just a minor fender bender, little scrapes in the car and these sort of things? That's the road safety risk. In a safe system assessment, what we've actually done is extracted out exposure in the likelihood. So what does that mean? Well, that means how many people are exposed to this risk. Then what's the chance of it transpiring in a crash? And how bad will those crashes be? So that's how we're thinking about risk in a safe system assessment. And to do a safe system assessment, you will quantify how many people are exposed to a crash. What's the chance the crash will happen? What are the characteristics of the road environment that are contributing to the chance of the crash? And then when it happens, how bad is it going to be? So those are the three key elements we're looking at in assessing anything's alignment with safe system principles. So I'll go into that in a lot more detail, but just to help you clarify that in your mind, what are we talking about? Things that would affect the exposure to crashes on the road network. Well, here's a photo. It's a little bit hard to see, but they've put a mound of dirt and a road closed sign on the other side of this railway level crossing. They have removed the exposure to crashes at this location. Okay, so that's an exposure example. Another example of removal of the exposure to crashes is if all of the cyclists and pedestrians are on their own separated path, they're not mixing with vehicle traffic, there is no exposure to vehicle to cyclist crashes in this, or we've lessened that exposure. There might be exposure to cyclist to pedestrian crashes, sure, but that other crash type, we've virtually eliminated the exposure. Likelihood is a whole lot of things out there that we've done for a long time that are lessening the chance of a crash. They're everything from sealed shoulders, audio tactile edge line, good line marking, RRPMs, lighting, surface conditions, even your geometric design, that's a likelihood type factor. Things like wide center lines, as you can see in this one, that's about the chance of a crash, lessening the chance that that crash will happen. It's not doing anything for how bad the crashes will be. It's just lessening the chance that they will happen in the first place. Traffic signals, they are all about the likelihood of crashes, trying to stop people crashing in the first place. This is an important thing to do, but You remember, that's what a set of traffic signals does. It reduces the chance of crash. The severity of the crash, when it happens, well, we really only have a small handful of things that we can use to influence the severity of crashes. We've got the speed, the mass of the vehicle, the angles that crashes happen at, the vulnerability of those involved, and the ways we absorb or dissipate energy. Because this is a physics sort of equation that we're working with here. It's the kinetic energy equation we're working with. When the crash is happening, how is the energy being managed? How much energy is there? And how is it being managed? So if you can slow vehicles at the points that they're going to crash, right, we lessen the energy transfer. Speed, critical part, or velocity, critical part in the energy equations. So something like a raised platform, slow vehicles at that crash point, the conflict point, that's going to lessen the severity of crashes. Or take a system like a road safety barrier, right? And a vehicle hits the barrier and dissipates their energy over time, right? They slowly come to a stop rather than hitting a tree with that abrupt stop, or a culvert or the like. That is about lessening the severity of the crash. As soon as they hit that barrier system, that's a crash, right? But the severity of it will be less. So you'll see throughout, like, the slides I use for the rest of this training, these little things will pop up, and I'll be saying, well, okay, barrier systems are all about the severity of crashes, and which is a nice tick there. Sometimes things might influence both the likelihood and severity, but I'll be just helping you out with that, because an important thing you need to be able to do as a safe system assessor is categorize things into either influencing exposure to crashes, likelihood of crashes, or severity of crashes, or some combination. So I'll be asking you to do that quite a bit throughout this course. And in fact, I'm going to give you a little assignment. It's a quick assignment at the end of this session, and you'll go away, look at an intersection, and start to categorize things into exposure, likelihood, or severity. And you will be marked on that one. Okay, so that's sort of caught us up to where we wanted to be at the end of last session. I'm just going to jump in here. We are recording. And this session is all about, I suppose, digging further into the infrastructure. We want to really start to unpack the kinetic energy thresholds for different crash types at intersections and at mid-block locations. So we will be thinking about that. Like, how do we determine how bad a crash is going to be at an intersection? We'll delve into that. We're going to look at mid-blocks and intersections today, and I'm going to get you doing a little bit of work around, well, actually fairly early on, which will be to think about an intersection from that exposure, likelihood, severity, and what we would do. Don't forget to catch your wallies, of course, and keep the questions coming in. Okay, so intersections are really a fascinating part of the road network from a road safety perspective. We certainly are all aware of intersection type crashes, as you can see on the screen there, vehicles hitting other vehicles. But the risk of road users being killed and seriously injured at intersections and around intersections goes up significantly for more reasons than just this crash that you're seeing on screen. Okay, so if you look at a route, for example, and I'll just draw a little bit on this here. And if this is risk, and this is, sort of chainage, you will see risk sort of bubbles along and then spikes. Okay, and it spikes at these intersections. It holds a certain degree of risk through mid-block locations. And mid-block, I mean between intersections, but it spikes at intersections. It spikes at intersections because of, yes, this crash potential, but also vehicles are more likely to leave the road at intersections. They're more likely to leave the road at intersections because of another vehicle entering the intersection, and then the vehicle with speed avoiding that vehicle, or clipping the edge of that vehicle and spinning off the road, or a pedestrian stepping out, or these sort of things happen. The other contributing factor to this is that we put rigid hazards around intersections. So when they leave the road, they're likely to hit solid objects. So it could be signal pedestals like this one, but we also have to put lighting there. We put power poles a lot at intersections because we want to turn a power line, don't we? It's got to go down that road. So we're putting those there. Often you're putting culverts at intersections because it's a point where you're going to need to get water to go under another road. So what we've done there is there's a spot on the network where we know there's going to be increased turbulence, increased activity happening, increased conflict points, and an increase in people's chance of leaving the road. Plus, we've made it much worse because they can hit a whole lot of solid things that have been placed around this intersection. So when we think about intersections, we want to holistically think about, yes, definitely these types of crashes. The fact that pedestrians are going to need to be crossing, that we're going to have bikes coming through, but also vehicles leaving the road and what they hit. Now, the Monash University Accident Research Centre came up with sort of some general principles for safe system aligned intersections. Now, these are very sort of generic principles. I think they're decent to think about because the first two they've got there, fewer vehicles and fewer intersections, we should be thinking about that. Like, can we get fewer vehicles going through this intersection, so lessen the exposure? Or can we have less intersections? Can we close off some intersections? Again, change the exposure. And I always like people thinking about possible changes to exposure as an early thing. Okay, the reality is it's very hard to influence exposure most of the time in practical reality, but we should think about it because it gives us our sort of highest alignment with safe system principles if it can be done. You definitely, if you're closing intersections, you've got to think about, okay, well, where are people going to now access what they need to access, or where are they going to come out? And are we just pushing the problem down the road? But nonetheless, it's a very good thing to think about. Then when you're starting to talk about conflict point analysis and conflict and intersection, right, that is a likelihood factor. So conflict points are about likelihood. Now, conflict points, if people don't understand what that term is, it's basically the different spots at an intersection that crashes can happen based on the path of road users. I'll show you a conflict point diagram later. A safe system assessment is not about doing conflict point diagrams. I mean, you can think a little bit about that way, but I'll show you one anyway. But then you see here, we're really thinking about all of the severity of crash stuff. And that's around, well, we know the tolerance of the human body. We know how much force we can handle before we break in different crash types. And we should be trying to align our intersections so when the crashes happen, they're within those tolerable levels. So what I'm saying there is it's really important is when the crash happens, okay? Because we've thought about reducing likelihood, we've thought about exposure. What we need to do is get that very distinct mindset of crash is going to happen. That's fundamental to the safe system, is to say, even if we do the best job we can in reducing the likelihood of crashes will still happen because humans will fall asleep, be distracted, drop their coffee in their lap, have heart attacks, all of these sorts of things will happen, right? How is the energy being managed in that crash? And then you see here, they've put some of the speeds and angles that we've talked about in last session. And I'll come back to those, but well, no, actually I won't. So generally 90-degree crashes for passenger vehicle to passenger vehicle around the 50 kilometers per hour is what we set as sort of a threshold speed. Above that, it's going to be really bad. Below that, it's getting better. Quickly getting better, and it's in the low risk sort of areas. Head-on crashes and the like, we're up around the 70 kilometers an hour. Anything sort of in between, if you can get some angle on your crashes, you're able to sort of get around that 60 kilometer per hour mark. So what do I mean by that? Well, go back to your year 10 vectors in your physics class if you did it. And, if you crash like that, the energy sort of gets pushed out to the environment more than crashing like that, where it's a smaller exit of energy into the environment. You bounce off a bit. Okay, so if you're able to do that, you get some better allowance for energy. Pedestrians around that 30 kilometer per hour mark or below. So again, I've put some tables up here with these figures. I want you to just really start to solidify these in your mind. 90-degree crashes between passenger vehicles, 50 kilometers per hour or below. Get some more angle on it, 60 kilometers per hour or below. Head on, rear end, 70 kilometers an hour or below. The only way you can run an intersection above 80 kilometers per hour, like operating speed I'm talking about, not speed limit, operating speed, is if you make it so that the delta V, the change in velocity, is within these limits. So what do I mean by that? Okay, you can have an acceleration lane, okay? And that vehicle then, the difference in speed between those vehicles, the delta V sits within our tolerable limits, and we're okay. You can crash two cars into each other if they're traveling 200 kilometers an hour and 210 kilometers an hour. That will be fine in the initial crash. Okay. They're going to, you got to think about how they leave the road then, if they leave the road. But that initial transfer of energy is within tolerable limits because the difference there is only 10. So you can see that we're now starting to look at crashes from this energy management, this biomechanics of injury physics perspective. That's when we've got to the crash is now happening. How bad's it going to be? So when you're doing a safe system assessment, you can sort of start to come up with this sort of stuff. You don't actually need to be this precise. I mean, if you're in CAD, you can easily do it, but you don't need to be this precise on angles. You can simply be saying to yourself, okay, right, they're building a new intersection here. Okay, a vehicle coming out here being struck by a vehicle there, that's pretty close to 90 degrees, isn't it? So that means 50 kilometers per hour is what we're thinking for the bullet vehicle speed. We want to be below that. We want to be 50 or below is what we want to get those vehicles down to at that point, because a crash is going to happen. Sure, we're going to do everything we can to stop that crash happening, but we've got to get our mindset in, okay, that's going to happen. So then we get over to the other side and we go, oh, okay, there's a bit more angle on that. So the energy's dissipated out a bit, 27 degrees. Okay, we can talk about 60 kilometers per hour for that side. That's about the threshold speed. Just a reminder there that we have secondary crashes to deal with at intersections. Vehicles hit each other. They don't, always hit each other this squarely. Sometimes they hit the back and they clip off. They hit the front. They avoid each other, but they go off in these different directions. Here's a diagram from the Centre for Automotive Safety Research at the University of Adelaide that took a whole lot of death and serious injury crashes at intersections, replotted them for secondary crashes that they identified that a secondary strike with something has been what's caused the death or the serious injury, not the vehicle to vehicle transfer of energy. And this has been a lot of clip off and the like. And of course, if you replot that to vehicles coming in this way, you probably don't need to do a lot of research. A bit of logic would say that, yes, okay, they're all going to, the bulk of them are going to be out in that area where they hit poles and culverts and have those secondary death and serious injury. Okay, what I'm going to get you to do now is, well, first of all, pop any questions you've got into the chat, but I'm going to give you a little exercise to do. And I'm going to give you a good sort of 7 minutes to do it or so. So it'll be a good opportunity to have your stretch and get your coffee, as well as write down your ideas. You'll probably look at it for a while, maybe have a stretch while you think about it, and then you'll write some answers into the chat. So Jess has got a question in there that's come in. So is promoting mode shift to active public transport a way to reduce exposure? So great question. The answer is it moves exposure, correct, right? So what you'll be doing is taking exposure of vehicle crashes and potentially putting them to exposure to cyclist type crashes. If you move to more cyclists, for example. Now, yes, there's a whole lot of benefits from that. We as safe system assessors sort of just make that call about where the exposure to crashes is. But if you could say halve your number of vehicles on the road by putting everybody into buses, okay, you have significantly reduced your exposure to crashes associated with vehicles, haven't you? You've reduced the number of vehicles that are going through that. So the chances of a crash happening are less because the exposure to crashes is less. So yes, that's correct. So it's a good one. Okay. So what we're going to do is look at this intersection. All right, so we've picked an intersection. It's in the sort of outskirts of a city, kind of established growth area, and it's got a highway here running at 70 kilometers per hour. Ooh. Oh no, what have I done? Okay. Running at 70 kilometers per hour. I'll just put 70 there. And we've got a side road here, which is 50 kilometers per hour. The main road here, the highway, has 22,000 vehicles a day. The side road has about 2,000, maybe a little bit more. That's a bus stop over here. You can see a shared user path here. This is a drainage structure, like a culvert. Water goes through there and out to this sort of area. We've got service roads here, two-way service roads. They're just servicing some houses. They've got some access points into them well further down. Up the road here, set of traffic signals about 500 meters up the road. There's another set of traffic signals about 2 kilometers down the road, or maybe a little less. Residential area. There's a school down this road, maybe 500 meters down the road. So let's have just a bit of a look here. You can see it from the view from the road here. You can see that's the side road vehicle coming out there. You can see a bus stop there. It's got lighting. You can see your two-way service roads over here. From the other direction there, you can see that drainage structure. That's your shared path over there. 70 kilometers per hour. Remember I said on this road, 22,000 vehicles a day. So what your task is to remove fatal and serious injury crashes at this location going forward. We want elimination of death and serious injury at this location forever. We want you to get as close as you can to that. Now, I'm going to give you some constraints here. You got a budget limit. Now, because I like you, I'm going to give you an extra $1 million. You're going to have $4 million to play with here. So you got a $4 million budget. You can't close off the intersection. I know you were saying to yourself, oh, no. Ken said that Monash University Accident Research Centre said, less intersections is very good thing to do. It removes the exposure. But we've done the community consultation, and it's generally unacceptable, and we can't close off the intersection as you wanted to. So that's not an option. Okay. And in fact, what we need to do is ensure that at this location, people can get in and out in all directions. So even making it left in, left out is not really an option for you. Now, the third one here is you're operating in your current political and organizational framework. So, you think if you're working in a council or in a department there, okay, I've got to suggest things that aren't like, I can't reduce the speed limit on the highway to 20 kilometers an hour because that's probably politically unacceptable at this stage. If you did want to do something like that, I would want you to come up with a little bit of a plan about how you would make that happen. If you're working as a consultant, think about your clients and what, might be able to go through. But apart from that, you're sort of free to do what you want, to change what you want within that budget, within keeping access at this intersection. But what I want you to do is for each idea that you come up with, I want you to either put a little E next to it, an L next to it, or an S next to it. So for example, you might say, okay, I want to improve the lighting at this intersection. And then you would go, is that going to change the exposure to crashes? No, it's not. The same number of vehicles are going to go through there. Is it going to change the likelihood of crashes? Yeah, it is actually, because people will be able to see more. They'll see things and they'll know there's an intersection, so they're less likely to crash. Is it going to change the severity of crashes? Well, no, not really, because I haven't changed any of the key physics variables, have I? I haven't changed speed, angle. I have not, got a way to dissipate energy. So then I'm going to say lighting and then put an L after I write that in. Now, some of you might be saying, well, I don't know how much stuff costs. I'm not a cost estimator. Okay, well, what I will do for you, this service I offer for this exercise is I will instantly cost estimate any ideas you have. And all you have to do is type it into the chat, whatever you're thinking, and I will tell you how much that will cost at this location. So for example, if you wanted to go with a grade separation, a big flyover, you want that, elevate that road over the top of this intersection. And I would say that's going to cost you $56 million and you can't afford it. So I'm happy to cost estimate and you are going to have a good sort of 5 minutes, even a little bit more to have a think about this. Also have a stretch, fill up your water or whatever you want, or if you're on your third coffee for the day, you can get into that. But I want, exactly as we're starting to see come in, list the things you want to do, exposure, likelihood, or severity after them, and we'll have a chat about that. If you want a cost, write cost, and then write the treatment that you want a cost for, and I'll happily do that. This is not an exercise in doing detailed cost estimation. This is an exercise in just checking we've got our head around what's exposure, what's likelihoods, what's severity, and how do we get absolute step change at locations like this. Okay, you've got 5 minutes starting now. So first of all, thank you for such wonderful input, everybody. I am absolutely loving this. So I'm going to just work through and talk to a few of the things that you've come up with. I'm not going to get through. I'm not going to get through all of them. I'm not going to be able to talk to everybody's ones, but I'll talk to a few things that stand out, and then we'll talk a bit in depth about intersections and the way you're thinking about it. This has been good. So we've had some comments there around changing the speed limit on the major road as a possibility. So that the speed limit, we know if we change speed limits, we'll get some reduction in speed. And that's going to reduce the chance of a crash and the severity of a crash when it does happen. You may not get the full reduction of the numeral value you're putting it down to, but you're going to get some reduction, which can be a good thing. But generally, anything we can reduce speed by, we tend to talk about reduction in the likelihood and severity of crashes. So signalizing the intersection, and Jess has done well there in saying that's a likelihood factor. And that I had just mentioned that to you, but absolutely. Signals are only likelihood, okay? Under a safe system assessment methodology, if you signalize something, it reduces the likelihood of a crash. So then we've got, okay, somebody's asked about a seagull intersection and potentially reducing the likelihood and maybe severity. So that seagulls are interesting. Now, those who don't know what a seagull intersection is, it's sort of, have I got my pen working here? Yeah. I mean, it's essentially sort of that. It kind of looks like a seagull is why it's called a seagull intersection. But a vehicle coming out sort of goes into this acceleration lane and then merges in from the right. Now, seagulls are an interesting one because in one sense, you've improved a crash angle there. You still, though, have a bad crash angle at that location, so severity kind of stays the same. We know we have a lot of trouble with merge from the right, and that's not a good merge because if you have, well, certainly like older people and a lot of people struggle to do that head check and that look and make that call. If you're in an articulated vehicle, your cabin actually is in your way from that ability to do that. So it's not a great one. So your kind of likelihood goes up at this location. Your severity might go down. You've still got the same there. Seagulls, there is a New Zealand tool, which is a seagull assessment tool, which is actually quite good, which shows you where a seagull style intersection will increase risk and where it will decrease risk. I'm not a fan of them, but some jurisdictions use them a lot. Nonetheless, it's an interesting one to point out. Now, where were we? We were going through. So seagulls. So we've got lots of people who are sort of landing on traffic signals. Sorry, lots of great stuff here. Okay, then we had the idea of trying to get more people onto the buses and reduce that exposure. So that's a out of the box thinking. I like that, and certainly has some alignment with safe system principles if we could do it. Barrier systems to protect road users from falling into those culverts and hitting things. So that is a severity reduction technique. Okay, then we've got a raised signalized intersection in there from Alan, both likelihood and severity. And that's right, that's spot on, because the signals are the one reducing the chance of the crash happening. The raising of it slows the vehicles down, which reduces the severity of the crash. We've got raised safety platforms, so that's the sort of same stuff. Now, the idea of a roundabout in there, and people are talking about, okay, likelihood, severity in there, potentially even talking about exposure. Well, a roundabout, really, we talk about, that's going to influence the severity of crashes. Now, we're going to slow vehicles on the approach, and then the angles are better, so the severity of the incidents is less. The reason we don't tend to talk about roundabouts as a likelihood reducing factor, even though they reduce conflict points, is that they tend to create quite a few minor bingles, rear end style crashes, little fender benders. I'll talk a little bit more about that shortly, but very interesting that people are sort of looking into that. Well done. Pedestrian underpass as an idea, changing the exposure to crashes. And so Glenn's put in there, okay, signals for likelihood, guardrail between hazards as severity, and potentially pedestrian underpass to change the exposure. The categorization there is just beautiful on 3 different things. I'm saying that's prize-worthy. So let's note that a prize for Glenn just for exceptional categorization. That's right, because the exposure changes. If you can take pedestrians away from crossing on the road and they can go under, then there's less of them exposed to crashes, right? The severity for the guardrail is because if they leave the road, they still hit the guardrail. There's still a crash. It's just less severe than going into that culvert. And the signals are the ones influencing the likelihood. So beautifully done. I'm just zipping through a few others. So wigwag sign, or a warning signs or active warning signs, we tend to talk about those as a likelihood. They're trying to alert to a danger. There's a little bit of an argument you could get some severity reduction out of it, but generally we just talk about that as a likelihood reducing factor. So, wow, lots of good stuff here. Now, there was some talk about relocating the bus stop. A couple of people have are not quite happy with where it is, and it's in a bit of a location where there's lots going on, and I think that's some good analysis. Is it going to influence the exposure, the likelihood or severity by moving that bus stop? Well, generally, we'd talk about it as a change in the likelihood of crashes if you've got a better location for that to happen. So we think about that because the exposure is sort of still there. We've still got the bus coming in and out. We've still got the pedestrians getting off the bus. We haven't changed the volume of that in this area. The severity is probably the same because we've got the same speed of vehicles. We've got the same crash types happening. But the chance of the crash is less because it's in a less awkward position of that bus stop. Okay, I might use some slides now because, again, I want to say well done to everybody on that. I'll come back to this intersection a little bit and unpack a few things, but we really need to be clear in our mind that a set of traffic signals reduce the likelihood of crashes, but that's all they do. Now, there will be some situations where a crash happens at a set of traffic signals that if they weren't there, it would have been higher speed and more severe. So somebody's seen it, they've braked late, they've gone into the intersection, a crash has happened, it's a little less severe. But there is still abundant possibility for a crash to happen at the speed of natural flow of that road. Okay, the free flow operating speed can continue straight through that set of signals. Okay, yes, they've got a red light and they shouldn't go through there, but there's nothing physical to sort of alter their operating speed. So that's why we talk about it as only likelihood. Now, signals are really a fascinating thing to look at on the public road network because there is a bit of a impression that a set of traffic signals is the ultimate for an intersection, maybe until it gets grade separated. But when you analyze any population center in Australia, actually, or pretty much around the world, you will discover that the biggest source of death and serious injury are signalized intersections. The location where most people are being killed and seriously injured in any metropolitan built-up area signalized intersections. And you can see here, I could grab this from anywhere, but I grabbed an outer sort of metropolitan Melbourne one, and just hotspotted death and serious injury. These are all large signalized intersections. Now, the exposure is high because we've got a lot of vehicles crossing here. We've got pedestrians crossing and we've got that. But the idea that that is our sort of ultimate form of intersection control is just wrong. They are a huge source of death and serious injury. Professor Jeremy Woolley, again from the Centre for Automotive Safety Research, he was doing a review of the National Road Safety Strategy, and during this sort of some investigations things, he made this comment like, traffic signals are the biggest failure of traffic engineers. It is a pretty provocative statement. But what he was saying was that you get in this mindset that you sort of, an intersection builds up from, okay, it's give way controlled, and then it gets some splitter islands, and it gets some other improvements, and then it goes to a roundabout, and then the vehicle volumes get so high that it gets converted to a set of traffic signals, and that's it. And then, yeah, you do mast arms, you do LEDs, and then maybe it gets red light cameras, and then that's it. Like, people need to start behaving themselves. Well, at some point in time, we need to realize if we build traffic signals the way we've always built them, we will continue to see people killed and seriously injured at them. It is so obvious when you look at this sort of stuff. That is major source of death and serious injury in the way we just always do it. And you see them just keep coming up time after time after time. New development, set of traffic signals. Oh, maybe this one will operate differently and people will obey all of the red lights and everything like that. No. Anyway, it actually reminds me of it. And in that little break, I grabbed something that I was thinking about, which was, let me give you a story. I was back in the Victorian government, it was about 15 years ago, and I was in the road safety department, and part of my role with a colleague was to review the designs that were coming in under a congestion easing program. It was called Keep Melbourne Moving was the program, and it was all about easing congestion in these outer suburbs, and so our role was to review the designs of upgrades to intersections to check them for safety. And a lot of these were the removal of a roundabout to change it to traffic signals, because you can get a bit more capacity out of your intersection with signals, and you can control things a little bit more, and you can coordinate traffic signals and the like. So I completely understand you can get a little bit better performance out of your network with signals in terms of moving cars around. So we would look at those and do an analysis, and we'd look at all of those things you'd usually look at in that, have they got the right phasing? Is it on pedestrian desire line? Are they using mast arms and LEDs? And, is the line marking correct? And all of that usual stuff. But we started, I'm just going to jump out of this because I grabbed the memo. Yeah, here it is. Now, hopefully you can see that on my screen. Maybe Marissa in the background, just shout if you can't see it. But I'm showing a copy of the memo that we used to put on the front of these designs that we would send back. Okay, yeah. So the Road Safety Department has analysed this project as, the Road Safety Department analysed this project as increasing crashes as follows. So project life, you've got to put a life to a project, an infrastructure project usually, in order to do any sort of calculations on it. But we said the number of deaths attributed to this project, 2.3 over those 20 years. Number of serious injuries attributed, 12.6. Put little people there just to sort of hammer home, these are not just statistics we're talking about. These are going to be people we're going to kill. And then said this sort of statement of acceptance. The above trauma is accepted by, and then left that line for the regional manager or regional director to sign that. Now, did we did we get any of these back signed? No, of course we didn't. Did we get some angry phone calls and then get asked to go into the executive director's office and we got the talking to of, come on, we've got to understand that a road authority's responsibility is, to balance, and you're not thinking about the overarching improvement. I'm like, the whole intention of it was to actually vividly place this in people's mind. If we are prioritizing moving vehicles through there a little bit faster, and we say that's more important than keeping these people safe, somebody needs to sign off on that. Anyway, it caused a row. We weren't allowed to put these on the front of them, and they all had to get destroyed, except for I took a copy. But the idea that traffic signals are the be all and end all, it is not correct. Funnily enough, nowadays, if you do a safe system assessment, it's a much more palatable way to actually present the information we were presenting with that memo, which I'll get to. Anyway, back to this. Okay, so a roundabout is all about reducing the severity of crashes, and it does an amazing job, actually. Now, I'm talking for passenger vehicle to passenger vehicle crashes here. We'll come back to pedestrians and cyclists at roundabouts because there are some problems and some challenges for us to deal with here. But if you're talking about an area maybe like this one, you can see here, fairly rural environment, not a lot of pedestrians or cyclists. I mean, a roundabout is a exceptionally high line safe system device. It reduced death and serious injury by about 85%, whereas a set of traffic signals, you get about 45% reduction in death or serious injury when you're going from a give-way sign to a set of traffic signals. Compared to a give-way sign to a roundabout, you're up at the 85% reduction. And it's predominantly coming about from the reduction in the severity of crash outcomes between passenger vehicles. But we do have those challenges with pedestrians and cyclists. We also have the challenges like the site you were looking at. You've got unbalanced flow. So roundabouts don't work as well with unbalanced flow. If you have a very sort of minor road coming into a higher volume road, it won't work well. Mind you, you can do some pretty good tweaks with metering roundabouts. So you put a set of traffic signals there, can nicely actually link into a shared path. There we go. Look at, I'm just designing up a nice facility here, but you just put a loop back in the road there. So as vehicles banking back, they can trigger the loop, hits those signals, flush some of them out. Okay, those ones are going to get banked back a little bit. You can do things to get more out of a set of traffic signals, but out of a roundabout using some metering and some other devices. But the whole point of I'm making here is that traffic signals in their own have this high severity crash potential that just remains. It continues to remain. That is not existent at roundabouts because of the lower speeds and the lower angles. Why do they need to be as big? Well, you can do small roundabouts. This is a very different road environment. You've lost some of that, advantage of the deflection, but there's a huge advantage you get here from a safety perspective. That advantage is associated with anybody approaching this spot. Well, nobody approaching thinks they have ultimate priority. So everybody approaching goes, oh, okay, I may have to give way, I may have to stop. Ultimate priority is a big problem associated with intersections. It's because people continue at speed and they're switched off. When they've got a green light, they're driving along, they're completely switched off, they don't change their speed, and they continue through. Same with give way control. A roundabout, though, or even a four-way stop type arrangement, or a three-way stop type arrangement, it disrupts ultimate priority. And that's huge wins. People slow down, they look around, they wake up. It's huge. If you're worried about the fast speed through some of these, you can think about raised platforms, slowing vehicles on the approach, all sorts of opportunities. Roundabouts do lessen the conflict points. So here's a conflict point diagram, vehicle to vehicle. I haven't put at this stage pedestrians and cyclists in. I'm going to talk about them in detail in the next session. At a passenger vehicle to passenger vehicle crash perspective, we see, you've got fairly minimal ways you can crash at a roundabout, much more at a set of traffic signals or a giveaway controlled intersection, and much more severe crash angle potential. Angle of crash is better, more energy deflected into the environment than this type of crash. So you bounce off a little bit. And this one's talking about like people drive in all states of consciousness. Gee, I wish everybody was alert and had a big night's sleep and had their cup of coffee and they were really attentive to the driving task. Well, they're not. I mean, people drive in just, they're half asleep. They're thinking about the fight they had with their partner. They've worked a double shift and they're driving to their sister's wedding for 2 hours. They're like, gee, we continue to work to try to lessen the amount of that sort of stuff happening. But so many people are driving not in a state that they are alert to the actual road network. But if you put a lump of infrastructure in the middle of the road, be that a roundabout or some sort of geometric change, they come back to it, they wake up, they look around. If you simply put a set of traffic lights and the geometry of the road is unchanged and there's no physical thing to navigate, they continue to be completely sort of tuned out to the driving task. Like you would have done it. You would have driven and you would have got to somewhere and go, oh my God, I can't even remember the last 5 minutes of driving or 10 minutes of driving. Like people get into these states, and it's not that they're bad people out there to but it's just a task that is somewhat monotonous and people tune in and out. We can activate them at that point of higher risk and that point of conflict to be more alert, be more aware, slow them down and lessen the energy. Just a little bit on roundabouts, because I do enjoy roundabouts. I like it's a little sort of hobby of mine. Roundabouts are not all the same. Now, we've got multiple lane roundabouts, then we've got like tangential roundabouts, radial roundabouts, and we've got the different size of roundabouts and all sorts of fun stuff, turbo roundabouts. You've got to sort of case by case think about all of this. I just want to show this because 2-lane roundabouts, especially with small radius in higher-ish speed environments, I mean, they perform pretty average in terms of the speed people go through them. That's the blue dotted line there. Single lane roundabouts really good. And then turbo roundabouts actually perform just as well as a single lane roundabout, even though they are a double lane roundabout. So I'll show you what a turbo is. And I do that for a number of reasons, because it's cool and interesting, but also because it's got some safe system thinking to it. So a turbo roundabout here, like it's got a raised separator. It's got a raised separator through the central carriageway. So that's raised sort of concrete separator. So if you want to do a right turn, you have to be in the right lane and you get into this sort of channelized right area. And you can, see that you can't take a fast straight line through it, which is a problem we have with 2-lane roundabouts. It helps with any sort of late maneuvers off. I gotta love this one too. Look, wouldn't even dream of putting a bike through that. So bicycle underpasses. This is from the Netherlands, of course. Here's another turbo roundabout. I just love this little picture for just what's going on here. We've got a truck that's entered into the roundabout, obviously made a mistake here. We've got this white van coming up here. And we don't know the scene here, except for we just absolutely know this is not going to result in death and serious injury. There is no way that car is going fast enough. So, I mean, they've got a radial style roundabout here. They just cannot have the speed to be doing damage. Even if they hit that at a decent speed, look at the angle on that. It's beautiful. They're going to bounce off, it's going to be great. So this mistake has been absolutely catered for by the design here and the choice of facility. And that's sort of safe system in action really there. And this one's sort of a bit of fun in the sense that you look at it and go, wow. And I was asking a Dutch engineer, this is again from the Netherlands. I was asking a Dutch engineer about this. So we had over, we're talking about cyclists, roundabouts and design of it. But it was more, I was just saying, well, this is fascinating. Like those types of roads in Australia this would just be a large signalized intersection. I mean, it may at some point get grade separated, but it would be a large signalized intersection, probably operating 2 roads at 70 kilometers an hour or 80 kilometers per hour. And the Dutch engineers just couldn't fathom the idea they did that. He sort of said, well, but what about all the death and serious injury to your community? How would you justify that? I'm like, I agree. It's ridiculous, but it's the practice. Like the whole philosophy would be that they'd rather do this with this massive land take and this complication than possibly run a standard crossroad signalized intersection. I think if you're on the ground, I haven't driven this, but if you're on the ground, this wouldn't be as complicated as it looks from up here. It's signalized. You can see where you're meant to go and things. But anyway, I just thought it's an interesting one. But it's good to see people are sort of working now on concepts for those large signalized intersections to say, well, can we think about this differently? Like, can we take some of those elements we know align well with safe system principles, slowing vehicles down, making people more alert, and integrate those in? We're still getting the capacity through some of these, areas that are designated high volume traffic routes, which are part of our transport network at the moment. And, these cut through roundabouts are interesting. Again, this one's a concept. The other one was actually real, but, the idea being that, okay, the bullet vehicle coming through here, they're going to get disrupted. In terms of they won't be half asleep going through this. They'll wake up to look around. They'll slow down. They'll have a slightly better crash angle. So, some advantages there. But it was really interesting to see that some of you asked about or suggested raised safety platforms on that little example we were doing. And that's kind of heartwarming to a degree, because I've been sort of running this course for about 10 years. And in the early days, nobody was really interested at all in safe system assessments, but we were pushing to get traction and trying to get a few people interested. But then in doing sort of these similar exercises, most of the time, nobody would ever suggest a raised anything on that main road we were looking at on the highway. And certainly, in my career, the start of my career, if I'd suggested any sort of vertical deflection, anything raised on a road with 22,000 vehicles a day, arterial on the highway, I mean, I would have been kicked out of the office. That would just have been ridiculous. But we've evolved from that to understand that this is not something that is the same as an urban speed hump or a car park style speed hump. These have ramp grades that are shallower. They're trying to just dampen speed and alert drivers to the presence of a conflict point to bring those vehicle speeds down. And so that intersection, the concept that the region came up with a lot of the thinking that you were all doing there in your 5 minutes, and it took a lot longer than 5 minutes for the region to sort of work through this, was they said, well, we'd love a roundabout, except for we've got unbalanced flow. It's going to be huge cost because of the size of it to get people around. It'd be 2 lanes, so we'd either have to sort of do some sort of turbo arrangement to run. It's not going to be the best. So traffic signals do seem to be the right option. We've got signals down the road and we've got signals back. It's a sort of consistent treatment of intersections, which has some advantages. But then they said, well, hang on, if we build more signals, can we expect anything different to what happens at all these other signal locations in our city where we're seeing death and serious injury? Is there something else we could do? Could we slow down the bullet vehicles? And the bullet vehicles are the ones here that are going to do the damage if they run the red light, if they go through there at speed. But vehicles coming in and out, they're target vehicles. They don't have enough speed to do damage in vehicle-to-vehicle crashes. So you don't actually need to impact on their speed. Like, even because it's a T intersection, you don't need to raise the whole intersection. You can just raise these approach points. And so they sort of took this option and they said, well, what about we do this? What about we know we can do just the likelihood with the signals, but we want to do something for severity as well. And so that's what they built. And, this one's out there. You can see it's a 50 km/h advisory speed. Why 50? Well, 50 because if we go back here, vehicle coming out, struck by vehicle coming through here is about a right angle. And remember, we said right angle, we want to try and get it 50 km/h or below. So that's what they're doing with the ramp grades. So you can work out your ramp grade to the operating speeds you'll expect through. There's some good tools to sort of calculate that. Advisory speeds to 50. And sort of there it is. Now, I was out there with a colleague doing the post-opening road safety audit of this. And like, this is a photo I absolutely love. I love this photo because I took it and we've got green lights. We've got the vehicle braking, which is saying that driver's alert. That driver is fully aware they're approaching this point. They're slowing down, even though they have absolute priority, right? They are doing that because they're approaching a higher risk spot on this road. And yeah, I've got the traffic operations people who get angry at it. They jump me and go, oh, this is inefficient. We're slowing everybody down for this very rare chance of something happening. I'm like, what a load of crap. Like, if we put a roundabout in there, everybody would slow down, and nobody complains about that from that perspective. Well, but it's accepted. This is because this is new. People are pushing back on it. So questions come in around, okay, well, what happens if a vehicle hits that at 70 kilometers an hour? Well, they don't. It's well sort of signed and marked, and they slow down. Now, it is sort of designed in a way that, they sort of they will damage their vehicle a little bit. But I mean, it's the same question if you had this in an urban environment, more lower speed environment. Say, well, what happens if a car hits a ramp that's designed for 20 km/h and they hit it at 50? Well, they scrape the bottom of their car out and they don't do it again. Okay, there was concerns in here around before this was built. Like, the list of concerns was huge. Okay, yes, there was concerns about this. What if somebody comes in here at 70 or even 80 or 90 and hits this? Are they going to fly off the road? Are they going to sort of Dukes of Hazzard style fly into the air and catastrophic crash scenarios? There was concern, well, what about freight? Are we going to break all of the freight? Buses, are people going to be flung out of their seats? This is an emergency vehicle, right? Are we slowing down ambulances and fire brigade? What about drainage? What about noise? These are all things that are worthy of investigation. But I can tell you now, there's enough of these that have been built out there on the road network, and there's enough evaluation of this to show that all of those things are nowhere near the concerns that people had in the sort of idea of this. They're not playing out. All that's happening is everybody's slowing down a bit, navigating through, they're more alert, and we're seeing big safety benefits out of these. So, the fear of the unknown was really heavy, but once you get a few of them in, people can start to calm down. Now, I'm not saying like this is what we absolutely have to do everywhere, but what I'm saying is that the principle here is that a set of traffic signals on their own still leaves high speed, bad angle crash potential on the table, and we see it play out. We need to rethink, and we need to start really hammering severity of crash at all locations where we know these crashes are going to happen. Another spin-off advantage of this was a reduction in the dilemma zone. The dilemma zone is a traffic engineering term or phenomenon where it's a point in time and space where a driver is in a dilemma when the signals go orange as to whether to put their foot down and go through or to brake. I'm sure you've been in the dilemma zone before if you're a driver. What we see with the Raise platform is like a virtual elimination of dilemma zone because, well, no, it's still there. It's just much smaller because people are already foot on the brake, slowing down to navigate over this. They just stop the bulk of the time. So another just sort of spin-off advantage. Yeah, so Andrew's got a good point there. And we talked about, okay, a lot of drivers running red lights because they're not concentrating, they're half asleep and the like. And then that's absolutely right. So the question is, well, won't they do the same thing with hitting this platform? The human factors element to this is that the vertical deflection is a far greater trigger to wake them up. So we really do see that not happen as much. There's been a lot of evaluation on this, and really people from the many weeks of video analysis that has been sort of done out on these situations and looking at crashes over 10 big intersections and the like, it's no indication that people are missing these compared to like the amount that they were missing red lights. But I think, it's something we continue to monitor, but it's a good point. Vertical deflection as well as horizontal deflection, so anything raised or anything that you need to navigate around, are very powerful things in grabbing drivers' attention and bringing them back to the driving task. Anyway, so we're seeing lots of these get out there. There's lots of good design guidance on these now. This one I particularly like, which is a roundabout in, so it was a roundabout. It's Dalton Childs Road in the sort of northern suburbs of Melbourne. Why do I like this? Well, this road here has 55,000 vehicles a day. It's a major bus route, heavy vehicles. Childs Road has something like 25,000 vehicles a day. This used to be a 2-lane roundabout and it was saturated during peak times, okay? There was a congestion easing program not very long ago. The congestion easing program said, oh, we should pull this roundabout out and we should replace it with traffic signals. But a safe system assessment was required as part of this because the Victorian government requires safe system assessments to be done on these sort of things. The safe system assessment clearly said you are going to increase the risk of death and serious injury associated with vehicle-to-vehicle crashes because speeds will go up and the like. You should do something to slow speeds down. You should raise this intersection, or you should consider a signalized roundabout or other alternatives. And so they went down the track of the raised intersections to get those speeds down as they go through. So you can see the safe system assessment did what that memo I showed you is doing, just in a much more palatable way. And I mean, these are big roads, big traffic roads, but we're slowing vehicles at these dangerous points. So pretty good, pretty great outcome, pretty good example of safe system in action. like to have seen that as 30, but not 20. But anyway, that's, little bits and pieces we can continue to work on. So you've got road design node 0307. If you want specifics of that, you can have a look at that from other jurisdictions as well. It gives you some good design advice on raised safety platforms on these more major roads. Austroads has released the effectiveness and implementation of raised safety platforms. Lots of good information. Got an example of one from New Zealand on there, but lots of examples of this. So if you're interested in the details of that, there's lots of stuff available. So I don't want you to, I just got to stress this. I don't want you to feel that, safe system, it means raised signalized intersections, right? No, safe system is a set of principles. It just happens that this is one way to play out those principles, that we need to be aware that people will run red lights or that there's potential for that. We need to engage them in the driving task. We need to lessen the severity of crashes. And this just happens to be a way that it can be done at these higher speed signalized intersection locations. Now, I'll just do one other example of, again, sort of safe system assessments playing a big role and the way we are thinking about the management of energy within the road network. So this is a location. We've got sort of the arterial road goes around that way. It's got, it's a medium volume. I think it's around 5,000 vehicles a day. And you've got sort of some more minor roads. High-speed roads, so it was 100 kilometers an hour on all roads. It did get reduced to 80 at one point in time, but there was still quite a lot of crashes going on and severe things happening. And so the region sort of looked at this and said, well, we'd like to build a roundabout at this location. And they looked at that, and then they discovered that the roundabout was going to, had to have some reverse curves on the approach. And then the roundabout itself had to be really big. And then you had to have all this land take around it. And it just became a huge exercise in land service relocation. This is like a telecommunication exchange building that had to be moved out. That was going to be like $1 million in its own right to move. It was just a huge cost exercise. So then they went and they said, oh, well, okay, we go, okay, we're going to do maybe some right turn lanes and some warning signs. And the safe system assessment sort of said, well, okay, you're going to help out a little bit with your right turn lane. You're going to reduce some of the likelihood of crashes. But you're still left with huge severity of crashes and the energy there is still high. Is there something else that could be done to reduce the speeds and improve angles and improve energy management? And so in this one, I was sort of looking at, okay, what could we do with a smaller roundabout? Not have reverse curves on the approach. And so this one, again, sort of utilized some vertical deflection to slow vehicles on the approach with very sort of shallow raised platform there, and then raise the intersection to slow vehicles. The reason that for this sort of slowing is you don't have those curves to chicane people in and slow them down. This roundabout is very small. In fact, that's the roundabout in the middle there. The rest of it's concrete apron. So you've got a sort of straight line possibility. So you're trying to look to slow people down. So this one again was built. You can see those sort of raised, shallow platforms, slow vehicles on the approach, slow them down again, get them through. Small roundabout, and then big tracking area where a large vehicle can turn and track over that. It's actually a little bit of concrete apron over there too. That didn't have to move, so that's saved $1 million in its own right. Okay, so this is a bit under half the cost of the I say the proper size, the big size roundabout. But again, it's not particularly that thing that I'm interested in. It's like the principles of saying we need to reduce speed, improve angles at these dangerous conflict point locations. It's no longer sort of acceptable, or we need to push harder than just some warning signs or a right turn bay or these sort of things. Like, don't get me wrong, those will improve safety a little bit in terms of reducing likelihood of crashes. But no, we need to substantially address the severity of crashes. I'm going to pop up a little quiz here, and it's not, well, the whole, yeah. And again, this may or may not come up on your screen. Don't worry if it doesn't. The question is true or false. Traffic signals are not safe system. True, false, or unintelligible question. Unintelligible question meaning that doesn't make any sense, Ken. What kind of a question is that? Yeah. So I'll let you ponder that for a couple of seconds, and then we'll keep ticking on. And hopefully I'm going to give you a little bit of time back this session to jump into that assignment. I will give you a good explanation of it near the end. I'll give you another 15 seconds to have your guesses. Ten more seconds. Okay, and end poll. Let's see what people were saying. Okay, so we had lots of false, lots of unintelligible questions. Well, I haven't given you any context here, have I? The first thing I'd say is that traffic signals in their own right are just traffic signals. It's not about that they're a safe system or not safe system. They're just a feature. The principles and the context in which they're applied are what determines their safe system alignment. The second thing is that we don't talk about safe system as binary. It's not something is safe system or it's not safe system. It's something aligns highly with safe system principles or doesn't align so well. So, I mean, unintelligible question is a pretty good answer on this one, but I could accept false if you had that idea in mind. Well, hang on, it's not the traffic signals. It's the context. And maybe the person who said true had a very specific context in mind of a high speed environment and the like. But I did want to put this up just because I have had some people leave this course and go back to their offices and say, well, you can't do traffic signals anymore because they're not safe system. And I was like, whoa, not the message. It's about the context and thinking through those principles. And so here's a few sort of key points in there. They're in the notes to recap some of the thinking, so I won't read through each of those. But let's talk about lane departure and mid-block locations. So we were now between intersections. Like, what are we thinking? How do we think about these locations? I'm going to start with these high-speed locations. Again, next time I'm going to talk. Next module, we talk about pedestrians and cyclists and sort of more of these urban mid-block locations and how we think about managing some of the risks for vulnerable road users and the like. But if we think about these high-speed environments, 100km/h roads usually, divided by a line, a center line, maybe some sealed shoulders, a little bit of cleared area, and then some trees and the occasional sort of minor intersection and the like. I mean, what I'll ask you, for this road, without knowing anything about it, what crash types do you think occur on this sort of 400 kilometers of road that continues on pretty much straight in this format? That's it. Straight onto it, everybody. Well done. Run off road and head-on crashes. Absolutely. That's it. Run off road and head-on crashes. The risk just exists and it continues on. It's not like a particular location has a demonstrably higher risk than another location. Okay, even things like these little curve, this little kink in the road, okay, there's a little bit more risk there, but the risk here is absolutely significant. So we need to understand that we've got to think about this as an unsafe environment for its entirety. People will fall asleep. They will leave their lane. And we need to start to alter the road environment so that doesn't result in death or serious injury. When they leave the road and they hit a tree, so what tends to happen is they're asleep, but they've fallen asleep. They've drifted off the road, usually to the left, just because that's the way the road is shaped in order for the water to leave. So they usually sort of drift off to the left, and they wake up off the road, and then they turn the wheel really quickly to get back on the road, and that starts the vehicle yawing. And yawing is that sliding sideways. Okay, and then we start to expose the side of the vehicle to point source hazards like trees and power poles and the like. So some people have this sort of impression in their mind that a vehicle drifts off the road and then hits a tree straight away. Now, occasionally that happens, a drift off crash, but more often than not, we just see this absolute chaos happening as a driver's waking up in the roadside environment, traveling at 100 kilometers an hour, and we see all sorts of things happening. And there's a lot of exposure of the side of vehicles, and that side of the vehicle there is absolutely horribly engineered for crashes. Like even side curtain airbags are just doing a little bit in terms of reducing the severity of crashes. We've gone up to 32 kilometers an hour. As I asked you last module, what's the speed that happens at? But, you know, we are nowhere near being able to survive side impact crashes at 70, 80, 90, 100 kilometer per hour into point source hazards like this, even in your best vehicles. Now, admittedly, the best vehicles are going to do a whole lot before you ever leave the road, and that's great. We're reducing the chance of the crash, but we do need to think about trying to manage the energy in these scenarios. Now, let's turn away if you don't like to see actual crashes, because this one is at estimated 60 kilometers an hour based on the on the frame rate here. The energy transfer in that and the violence of that crash, it is unsurvivable. And that's showing you, and that's sort of estimated around that 60 kilometers an hour. The amount of energy in these is just astronomical, unsurvivable to humans. So we used to go with this concept of clear zone in these rural environments. You know, let's clear the road of hazards, clear the trees, move the power poles back, move the culverts out, okay? So that theory, the clear zone theory, has been around since the 50s. The research behind it was always a little bit iffy as to why they came up with certain figures. And what it really was, and there's been lots more research on it, it shows here that, you know, vehicles, yes, get some advantage because they can recover in these early bits, but they in these early sort of bits. But then it sort of asymptotes out anyway. Like if we look here, run-off road casualty crashes per 100 million VKT. I'll give a prize for somebody who can tell me what VKT stands for. Make sure you're still with me here, everybody. Well done, Jess. Another prize getting shipped up to Queensland. We see it sort of asymptote out around that 4.5. Like you can just keep clearing your roadside and you're still going to have people go beyond it. They're going to roll over within these cleared areas. So you're not sort of getting your ultimate there. There's a second really important one is we don't want to remove trees. We want to keep as many trees as we possibly can. So it's the roadsides are just wonderfully rich areas for biodiversity and lots of native vegetation and like because some of our sole remaining areas of good stuff. So like what we're saying about clear zones is okay, a wide clear zone forever is not necessarily a safe place to be. People will go beyond these fabricated clear zone and there's rollovers that can occur. The first 4 to 5 meters can give some real benefit, but the new, well, actually, I'll come back to that. This is the old way that you would design a rural freeway. So you'd have a big sealed shoulder, you'd have calculated a clear zone of like 9 meters or something. There'd be a whole lot of trees down at 9 meters. Probably wouldn't have these. You'd have a calculated clear zone median, and that would be clear of hazards. And that would be it. You probably wouldn't have truck rumble strips. That's a bit of an innovation. But the reality is that you build this in accordance with those standards. Vehicles still leave the road. They still hit these trees. Vehicles go all the way across this carriageway. They have head-on crashes. They get to the other carriageway. And when I say the old way of doing it, I'm talking about 2 years ago. This is how a new road would be designed. And it's absolutely just like, it boggles the mind that, we did Princess Highway duplications were happening up in New South Wales, and you'd see these sorts of designs come out. The minister would cut the ribbon on a $1.5 billion upgrade. And then within a few months, like a vehicle leaves the road, crosses the median, hits a car carrying a family, 6 people dead, in a brand new $1.5 billion road asset. Like imagine that if it was a train line. They spent $1.5 billion building a new train line. A couple of months after it opens, 5, 6 people dead. The line would be just closed until all of those risks were rectified. It would just never happen. But we're so numb to this in road safety. But anyway, the point being, you would not build a road like that these days. The new Guide to Road Safety Part 6 helps us a bit. Sorry, the Guide to Road Design Part 6 helps us a bit with, and there's a lot to unpack in this. It uses a thing called NRRIT, Network Roadside Risk Intervention Threshold, and you've got to calculate this and work through it. But like in a very simplistic term, from safe system principles, from our highest alignment with safe system principles down to our lowest, we see continuous barrier systems. You don't need all of that wide width of cleared areas because you're going to have continuous barrier systems. They are our best alignment with safe system principles. I was showing this to somebody and they said, oh, well, it's like the bumper bowling of roads. So yeah, that's a fair description. I mean, people will leave the road. They will leave their lane. We need to create an environment that sort of catches them, that is designed for that. The past was designed to try to eliminate anybody leaving the road, and that's not going to happen. Okay, we can sit. I'm not saying we stop that. Yeah, we want sealed shoulders. We want audio tactile edge line. We want initiatives to try to keep people awake. We want rest areas. We want good education and all these sort of things. get all of that right, people are still going to fall asleep. They're still going to leave the road. We have to think about the severity of the incident when that happens. Now, they cost a lot of money to do this, but for our highest volume roads, that's what we should be doing. If you want speeds to stay high, you invest in the infrastructure. If not, you're going to have to look at lowering the speeds down in these roads. Just a little aside, and I better take you through your little assignment shortly and answer any questions anybody's got. Just an interesting one, like hard to sort of see here, but a road with this big sort of 10-meter and more cleared median, sort of roadside, cleared roadsides, that's a 4-star road. So that's like, so we do safety star ratings of roads the same way your fridge gets an Energy Star rating. We can safety star rate your roads. It's part of IRAP or OzRAP, and you can officially do that. So 4 stars, so that's not bad. I mean, but a 5-star road here has the barrier. You can see it's a smaller cross section. It's a smaller envelope we're taking as well. And that's our sort of highest alignment with safe system principles. I'll jump through those. They're in your notes if you want to have a look at them. Of course, there's a lot of details in barrier design, thinking about how road users are going to use it, breakdowns, transitions, deflection, working with. There's a huge amount in the details of it, so it's not as simple as just putting it out there. I'm not going to go through that. This is not a barrier detailed design course. This is about sort of thinking about those principles so we can assess. I'm going to finish with this one and then take any questions that come in. This is a high-speed crash that happened in Mildura. It involved a scenario that's all too common. It was 2 a.m. There were 4 young males in a old Ford, and they were driving at a reasonably high speed. They went through a roundabout, and I just talked to you about how awesome roundabouts are. Well, this one crashed off the roundabout, but they hit a power pole. Now, all 4 passengers survived, minor injuries, leading a normal, healthy life, as I understand. There was a forensic crash investigation report that estimated they hit the power pole somewhere in the order of 90 kilometers per hour. Okay. Everything we know about physics of point source hazard says that they should be dead or, carrying debilitating brain injuries and injuries for the rest of their life. But this one had a thing called a Raptor cushion around it. And that there is a really fascinating device. And again, I'm not saying this device, I'm not trying to sell this device or anything like that, but the principles of it are really good, because what it does is it thinks about energy management, not just from the crushing perspective. Like, it is a cushion in its own right, but it also rotates. It's not connected in the ground. So it rotates and it redirects energy as well. So a vehicle will hit it and it'll also direct off as it rotates, which is a wonderful sort of kinetic energy thinking, kinetic energy management thinking device. So I just sort of wanted to add that in. The reason I sort of end on that one is because it's yet another example of us thinking about the management of energy. And so the big changes in our industry is that we now need to be thinkers of energy management in crashes. I think we have all in our industry been very comfortable with trying to stop crashes happening. Good sight lines, good signage, warnings, these sort of things. But now we're thinking, okay, we've got all of that right. We have to get all of that right, but crashes are still going to happen. How do we manage the energy to keep it within these tolerable limits? Okay, so I'm going to just jump out of this. I'm not going to do that quiz. I'm going to jump into the learning management system. Actually, might have some questions, it looks like. So barrier systems look terrible. Is anyone going to make them look any better? Well, that's a really interesting question there from Joseph. So a couple of things on that. You can paint barrier systems. There's nothing stopping you doing that. So if you wanted to do that, there are some timber-faced guard fence systems that kind of look like a nice old wooden fence, yet sitting behind the timber face is the metal barrier system. And there's only there's one of those that is MASH tested, and MASH is the Manual for Assessing Safety Hardware, which is the test protocol we need to undertake to get sort of a system approved. It's only sort of for lower speed environments, 60 km/h, 50 km/h roads at this stage. But often, those do coincide with some of the more areas that people aren't as happy with the look of barrier systems. But the barrier system's only there because there's the high speed, usually potential for people leaving the road. So in those high speed environments, you can look to lower speeds and get your safety outcomes that way. But yeah, I do agree. There's some situations where it's a fairly big impost on the aesthetics of an area to put a barrier system. So a few little things there to help. Happy to point you at those if you've got specific locations in mind. Okay, so you're all very comfortable and at home in the learning management system, no doubt. We've got the resources there, reference documents, which you're good at. We're going to go to module 2 because we just finished module 2. So the presentations, the PDFs are there. You've got a safe system snippet on traffic signals versus roundabouts if you want to have a look at that on our website. I've put in there that effectiveness of raised safety platforms, Austroads report. Now, there's an actual 1-hour webinar on that as well, which is worth watching. I was compact roundabout design note, which is that one I showed you, that compact roundabout. And then what we've got here, there's a technical report on that intersection, raised intersection that we were doing as an example as well. Lots of little things if you want to, but these are the 2 key ones that you're going to have to go to. So you've got your quiz as usual, just to check you were paying attention, you got everything for today. And then you have to do this little assignment. Module 2 assignment. So you click on that. Hopefully this will work. Okay. So you can see here that you've got 4 days to do it. So we want it done before next module because I'm going to ask for volunteers to talk us through. You've got 3 attempts if you needed it. You are going to be marked on this. You're going to be graded. So you click on the PDF there and you open up the PDF and it's got instructions for you. So step-by-step instructions. I'll walk you through these now. What you're going to do is fill out your name. Should be able to edit the PDF. Okay. What we want here is you to pick an intersection. Now, it can be any intersection. It could be the one out the front of your house. It could be one at the front of your office. It could be one that you are thinking about from Street View. It could be one that you've got residents that got concerns about, whatever it is. All right. And then we want the coordinates of that or a Street View link or something put in there so we could have a look at the intersection too. You don't need to go to this intersection. Okay. We're doing this one as a little desktop exercise. It's a bit of practice. So you paste in there the Street View or something to that. Then what we want you to do is list for us factors that increase or influence the exposure to crashes at that intersection. And we can have between 1 and 3 listed in there. Then we want factors that increase or influence the likelihood of crashes. We want between 1 and 3 listed there. Factors that influence the severity of crashes, between 1 and 3 there. And then we want one change that you could make that would influence exposure, one that would influence likelihood, one that would influence severity. Now, you're not being constrained by budgets or any of these things. This assignment is to check that you understand what's exposure, what is likelihood, and what is severity. So you might put in here, okay, well, what's influencing the exposure? This is a high volume arterial road. There are lots of pedestrians crossing at this location. These, numbers. I'm going to put like numbers. This is what's creating the numbers of crossings, number of vehicles, all right? And then maybe you say, well, I'm going to do a grade separation, or I'm going to, some way that would change the numbers of people exposed to crashes. Likelihood, it could be anything, is it a confusing intersection? Is there a see-through effect? Are the warning signs hidden? Are the bad sight lines? Is there surface issues? Okay, and you're going to fix any of those. Severity, well, we've got, what do we got to control here? We've got, what are the influences here? Speeds, vulnerability of users, angles of crashes. These are the sorts of things that might influence the severity, and you can change them in a number of ways. So hopefully throughout today, you've got a better idea in your mind what's exposure, what's likelihood, what's severity. You're going to actually try this on a real intersection and thinking through, categorizing, okay, what's exposure? What's likelihood? What's severity? Display them. Save your PDF on your desktop or whatever. Add submission. Drop it in there and save your changes. It will then be looked at and marked. And as I say, next session, I'll ask for a volunteer. We'll, as a group, dive in on Street View. We'll have a look, we'll talk through, and we'll talk through that categorization of exposure and likelihood and severity and some of the risks that exist at that location. And what are some of the ideas that you came up with to address exposure and likelihood and severity? So you don't this is a 15-minute exercise, right? If you're spending a lot longer than that on it, you're probably going too much on it, maybe a little bit longer. But if you it's not a 2-hour exercise. Okay, you can do it very quickly. You pop it in there, you pop your ideas, you have a look at it, and move on. Do your quiz, and if you have any issues, any troubles, yeah, sorry, I was just looking at the quiz there. If you have any challenges, any issues, get in contact. Don't sit there, getting worried and confused. Simply shoot an email through or pick up the phone and give us a call, and we'll clarify it and we'll help you along. Remember, if you submit it and you got it all wrong, all that will happen is you'll get feedback. So you'll get a low mark, you'll get feedback, and you'll be able to resubmit. And your mark will be able to go up to whatever you've resubmitted at. So any final questions? You're clear on your task? It's not a huge thing, hopefully. All right, well, I want to thank you all for the wonderful interaction today and getting into that intersection design thinking. Exposure, likelihood, severity, important factors to do a safe system assessment. You're having a bit of practice at this. You've got 5 minutes left in our allocated time, so why don't you get started, do that quiz, maybe download the document and get yourself moved along before the weekend. Thanks, everybody. And I'll see you a little bit early for the next session for a couple of trivia questions. Have a good weekend. Bye.